Hi, so first we will be talking about benchmarking and why it's important. So, benchmarking means measuring how fast or efficient a piece of code is. It's especially useful when we want to compare different methods that do the same thing. So, benchmarking helps identify why is the code slow, so improve speed and make smart decisions about performance is the first step in optimizing your code. Then we'll be talking about GMH. So GMH stands for Java Microbenchmark Harness. It's a toolkit that is designed specifically for benchmarking small pieces of code, like one method or one loop. It solves major problems in benchmarking. So it automatically runs benchmarks many times and gives you the useful metrics like the average time, sample time, shot time, or throughput. So here we'll be running the benchmark runner to see the main features of GMH. So the first feature is warm-up iterations. Warm-up is when GMH runs the benchmark a few times before actually measuring it. And then the iterations are how many times GMH measures the method after warm-up. And forks forks tell GMH to run the benchmark in a completely new Java process. So it's a voiced interference from memory, caching, or previous benchmarks. So here we're trying two iterations. And this compares the time for both. And we'll be talking also about the benchmark modes, like average time that we're using here. Like GMH supports different benchmark modes depending on what you want to measure. And here we want to measure average time. And for POM here, so POM includes all the dependencies we need in our project. So here we're including GMH core, which contains the main benchmarking engine, and GMH generator, which enables annotation like benchmark. And here we have the code done. And it's comparing both methods.
In this short video, I will walk you through how we use Java Micro Benchmark Harness or JMH to compare the performance of two different string concatenation methods in Java. So here we have our Maven file, the pom.xml, and we will focus only on these two dependencies, the JMH core and the JMH generator and process. So these two dependencies will allow us to use the JMH in order to benchmark our methods. So here in the sample code, in the code base, we have the string concatenation method, the first one that uses the regular plus operator with a for loop, and we have our second method which uses the string builder built-in method in Java. And each of the two methods are marked with the @benchmark in order to indicate for the compiler that we are going to use benchmarking, the JMH benchmarking for these two methods. Here in the top we have the state that defines the scope.benchmark, and we have the benchmark mode.average time. So the benchmark mode.average time tells the JMH to measure the average execution time per method call, and the @output time unit tells the JMH to use milliseconds as the measuring unit. This sets the unit of the measurements to milliseconds, and you could change this to microseconds or nanoseconds if you need a finer granularity for your tests. So here in our main class, we have test that uses the fork and the build methods, and we're gonna run it. In order to run the benchmark, you just need to right click and select run benchmark run.main. I've already made this step in order to save time in the video, and I have already have the output here. Okay, so we can see here that JMH runs on two different forks. So the first fork, fork 1 of 1, is testing the concatenation method using the string builder. And we can see here the two warm-up iterations and the time they took in units milliseconds per operation, because we are using the average mode. And we can see the two original iterations after the warm-up iterations, and we can also at the end see the result for testing the concatenation method using the string builder. And you can see that the final average time took is 0.005 millisecond per operation. For the second fork, we have fork 1 of 1 for testing the string concatenation in the for loop, the method that uses the for loop. And we also have here two warm-up iterations in order to prepare for the test, in order to have steady results. And we have the two original iterations that took significantly more time than the concatenation using the string builder. And we have the final result as 0.371 millisecond per operation, which is also significantly larger than the time that took the string builder using the built-in string builder method in Java.
My name is Pida, and in this part of the video I will be covering some performance testing tool used for Java applications, and I will share our team experience working with GMH. So I will start with the first tool, which is Visual VM. So let's see it. Yeah, so this is the website for it. Like, it's a free tool that come with the Java development kit. Visual VM allow you to monitor CPU usage, memory consumptions, garbage collections, and thread all in real time. It's very useful when you are running full Java applications and want to analyze how it's behave. However, it's not designed for benchmarking small pieces of code like a single method that where GMH perform better. The second tool is gprofiler. It's offer a very detailed profiling, including memory usage, object reference, thread, and even database access. It's especially good for large enterprise applications where deep performance analysis is needed, but it just like visual VM, it's not focused on methods level benchmarking, and it require a paid license, so it's not free, which make it less accessible by the student. The third tool is Java Mission Control, often is called GMC. It's work with Java Flight Record to collect performance data for long-running application. One of its strengths is that it has very low overhead, so it's perfect for analyzing performance in a production environment. Still, it's focused on monitoring whole applications over time, not individual method like GMH. now like talk about team experience. Now I like what was easy and what challenge that we have. What was easy was the running the benchmarking after set up. GMH gives clear results like average time or throughput, and its handles warm up and multiple run automatically. What was a challenge was configure the .xml file correctly, understanding how annotations processing work, and getting the benchmark to run properly in IntelliJ. But overall, like it gave us a great opportunity to learn how benchmarking actually work in Java and how the GVM optimize code over a time.